Good morning. Thank you very much for making the journey to King's Cross, to the Parcel Yard, to this old Victorian sorting office. So this, if you posted a letter 150 years ago from London to Edinburgh, it would have been sorted through this particular location, which is why it has such a unique style. So this is the first in-person event that we've run for more than 2 years. So it's a bit like, you know, waking up after a very long sleep and getting back. So I really appreciate you making the effort to be here. It is very much appreciated. We are taking video today, as you know, because we're going to publish an edited version of this workshop. So if you want to come back and refer to it, you can see bits of it again. But also for others who were not able to be here, but who think it's important, they'll be able to watch it. So this will be a lasting piece of valuable content. Now, my name is Robert Owen. I run the university program for Imagination Technologies, and I'm sure you're aware we're a medium-sized British company who create designs of GPUs and other IP like CPUs and neural network accelerators. And the subject today is all about graphics, and the objective of our Introduction to Mobile Graphics course is to help teachers introduce this subject, and it's a pleasure to have the author of the materials here to present these materials to you, to show you how you could use them in the classroom. So without any more ado, I'd like to hand over to Darren McKie from the University of Hull, who will lead today's workshop. Thank you.
Thank you, Robert. Okay, so forgive me for sitting down. This is quite a sort of surreal experience because usually in a lecture theatre I'll be stood, but my knees won't let me stand all day. So, so this is me. Okay, so I've been an academic for over 20 years. From the Department of Computer Science and Technology at the University of Hull, I actually started my sort of teaching career way back when there was a PGC HE, which then the Higher Academy and so on all came in, and I'm a fellow of the Advanced HE. I've been Director of Student Experience for the school. I've been Director for our Games Development courses. You know, I've been around the block, okay? I teach, I do some research, but most of my research is actually pedagogical, okay? So I'm very much, yes, I'm an academic, but I'm very much a teacher, okay? And in fact, I always kind of describe myself as I do research so I can teach rather than the other way around, okay? I do lots of outreach, so I'm actually the outreach coordinator for our school, and so I like to go out and I do lots of presentations and workshops with schools and colleges and things like that. So yeah, that's me. Now we've got a range of people with us today, okay? Mostly academic, but some sort of non-academic sort of teaching people. But I'm going to start off with the pitch, okay? So what I've developed with Imagination Technology is an entire module, okay? Now terminology depends on where you're at, okay? So it's an entire course block or module that you can take and use, okay? Why would you want to teach mobile graphics or learn mobile graphics? Well, there's over 3 billion smartphone users worldwide, okay? A few years ago, in 2018, the gaming industry as a whole, okay, actually managed to get just over 130 billion US dollars, okay? Now, around half of that was for mobile gaming, right? So there's enormous, pool there. On my train yesterday coming down to London. It was a 3-hour train journey, and I was playing games. Okay, so the fact that particularly whether it's a disposable game or even a quite sophisticated game, there are so many people. Pretty much everybody, at least in the developed world, will have their own mobile phone. So being able to teach students how to make mobile games, okay, in particular what this module is about teaching them how to do mobile graphics, okay. It's very much about the graphics, but once you know how to basically create your own graphics, then there's a lot of transferable skills. So virtual reality, now this is something we also teach at Hull, is just an extension of games, okay? A virtual environment, most games are virtual environments. They're just rendered onto a 2D screen, okay? Whereas VR, you're just rendering it twice, once for each eye, okay? So, there's a lot of transferable skills. And when we start, in the full module course, we look at lighting models, a lot of the mathematics knowledge within that and understanding that, because when you're actually writing your own graphics code, you have to write it yourself. So understanding the mathematical models, applying them to lighting, can be transferred to AI, sound, and lots of other things. So just going to do an overview of the full teaching materials, and then we'll look at what we're doing today. So I've developed the package so that students with little or even no previous knowledge of graphics can do the course, okay? Now, it is based on C++, so they would need some C++ experience, okay, so it's not teaching C++. The framework that utilizing is built on C++, but all the graphics code, the shader code, as we call it, the package assumes little to no previous experience. So it depends on the institution you're at, but I would suggest either second or third year undergraduate degree, possibly MSc, depending on when they or when your school or university actually cover C++, or any sort of gaming, and even then just general computer science programs. Okay, I know in Hull we do quite a lot of graphics. Start off with 2D and then go into sort of 3D. Then we've got advanced. Then we've got both of those are actually used. Well, one's using C#. One then uses sort of WebGL things. Then we go into the C++ with DirectX and lots of different things. Okay, so it depends where it fits with your students. So the full teaching package is comprehensive, and it covers a whole range of topics within this sort of umbrella. So it's not just like here's the code. This is what we also need to appreciate what's going on, particularly with the mobile architectures. Okay, you cannot, unlike a desktop, where you can kind of throw code at it, and they're so powerful you can get away with things. When you're looking at mobile architectures, you really need to understand what's going on. Okay, and today we will be looking at that. Okay, everything you do on a mobile device uses power. Okay. As soon as you use power, the battery drains. So if you're not careful, a user can be playing your game for, say, 30 minutes, and they've got no battery left. They're never going to play your game again. Okay? So there's a lot more to it. But ultimately, we'll be looking at lots of things. So obviously the actual mobile graphics itself, but understanding what SDKs you can use, what texturing is, and that's applying an image to a triangle, for instance, how we can manipulate the triangles, the meshes in the environment, lots of shader code, and even lighting models, as I've already mentioned. Now, I use the Imagination Technologies PowerVR SDK. Okay, so that is the main framework that the teaching material is based on. So it is C++, but it's a platform-independent API, basically. So what this means is you can develop on a Windows platform, you can develop on a Linux thing, Android, Chromebook, and in fact in the full teaching material, as I'll show you in a little while, there are optional practical lab tutorials in there that show you how to deploy to Chromebook, as well as embedded devices like the BeagleBone Black, like I've actually got here. And I'll actually be showing a demo of the work on here. And because the PowerVR SDK is platform independent, all you have to do is copy your existing code to your new platform, compile it, and it works. It doesn't need any changes at all. Okay, so it's really, really nice. So if you're doing embedded devices, then you can still work because it actually has an emulator, which is really, really nice. So you don't have to develop directly on the embedded devices, which can take a little bit of time because they tend to be slower at compilation. So you can work on a PC and then just copy it across, or I always publish to GitHub and just clone it directly to the device, compile it, and you know it's going to work, and so on. And also, there's lots of tools within the PowerVR framework, including things like texture compressing. It will load meshes for you and textures, and it does all the stuff that we don't really care about. Okay, what we want to do is to create our own graphics. So the format of the teaching materials, there's full lecture slides, and what I like to do is actually integrate the presenter notes directly in the slides. There's lots of all the practical exercises are there, including the model solutions. And in fact, the package that you've got today for the workshop does include all the worked solutions for all the practical labs anyway. It also has some exam questions if that's what you do at your institution. So the lecture topics mostly cover high-level things, okay? But we also do address and introduce the shader code, some of the C++ OpenGL functions that you have to use to get the CPU to talk to the GPU. But very much about lots of practical materials to help the students come familiar with the framework and how to make graphics. So why actually learn how to do graphics yourself? Because you could just use Unity or something like that, you know. You can use Unity, you can drag and drop existing shaders, compile it for Android or something. That's all well and good, and if you're doing a really simple 2D thing that doesn't, you know, then fine, I guess. But going back to my earlier comment, just because it works doesn't mean to say it's good for a mobile device. So everything you do, and I'll say this several times today, everything you do on a mobile device uses the battery, okay? It's using power. So actually understanding and writing your own graphics and game from scratch, essentially, means that you're more in control of what's happening. You're not just utilizing Unity. That could be doing anything, and probably using an awful lot more power and therefore battery than you can do by actually writing your own shaders, making sure they're efficient, and understanding the architectures as well. So, on completion of the module, students were able to write their own shaders. Okay, it's OpenGL ES. Okay, it's ES because it's for embedded sort of systems. Okay, which is just a sort of a subset, should I say, of OpenGL. So if you know OpenGL ES, you will know OpenGL. Okay, you'll be able to use those quite nicely. So I've been looking at, I've tried to make it as flexible and as modular as possible. I appreciate that different institutions have different formats. Some have semesters, some have terms, some have, so I've tried to make it as modular as possible, so you can kind of chop it up. You can use parts of it as you see fit. There are around 40, and again, it depends on who's obviously delivering this, but I would estimate there's around sort of 38 to 40 hours of content here in lectures and practical work. And in fact, if you use the optional, the Chromebook and the BeagleBone Blackwork, it's probably more than that. Okay, so there is a significant amount of content here. So just to show you some of that, okay, this is the lecture topics for the full course. Obviously, we don't have 40 hours today to be able to go through everything, so we'll be looking at the first parts. But today I will be sort of presenting the first 4 lecture material. Just so that you can see what it's like to be a student, how easy, I believe at least, it is to sort of pick up and understand what's going on. But there's everything from, obviously we're going to, the first lecture is to introduce what mobile graphics is, the basics of the PowerVR framework, actually understanding the mobile graphics architectures, again, because of cross-platform nature and being able to understanding power consumption and so on. That's really, really, really important. Okay, so I've put that quite high up. Looking at what mobile graphics SDKs are, and then going into texturing. So how do we apply images to our texture, to our triangles and things? How do we manipulate our meshes in the environment? Looking at how do you write shader code? And if you're unfamiliar with that term, I will be covering this in detail. How do we do lighting directly on the GPU? Reflection, refraction. These have been available since OpenGL 2.0. Okay, and also just an introduction to Vulkan. Okay, and in particular the sort of comparisons with OpenGL ES. Now, there is some, in fact, within the first 4 lectures, as you will see, I do touch upon Vulkan when we're looking at different graphics SDKs and so on. And there's also all the lab work that goes, the lab tutorials that goes alongside all of these lecture content. So this is what I would propose, and again, it depends on how many weeks you teach, whether it's terms or semesters and so on. But for the lecture material, you can see that I would suggest that each of the labs, in fact, the first one may need more than one lab, Again, it depends where your students are coming from, how much C++ they've done, if they've done lots of object-orientated. So if they're in the third year, they'll have done all that, so you probably only need one. If this is sort of the beginning of the second year, they might not have done an awful lot. They might need a little bit more support. But in terms of the labs, you'll be all doing the first 2 labs here. So the first lab being able to actually get something working on the screen, understanding what the frameworks like, and actually moving some of the C++ OpenGL code around into your own class, so you can start to understand how you would build your own OpenGL code and so on. And then the second one is understanding the SDK framework. One of the reasons I say we'll be using this is the cross-platform nature, the fact that you can just deploy to another device, compile it on that device, and it just works. But there's a huge amount of things that you can do with the SDK. Say it will load textures for you, it will compress them, it loads shaders for you and assets and things. So it's all the stuff that we don't really care about, okay? We want to get hold of those things, and the framework does those things beautifully for us. And there's also, say, an optional lab that shows you how to deploy to Chromebook or an Android device. There's practical labs actually allowing the students to do their own texturing, and then actual transformations, directional lighting, and then point lighting. All of that is in shader code. Reflection, refraction, again, in the shaders. And then to understand the performance, there's a lab using PowerVR Trace, and we'll look at that. But it's one of the tools by Imagination Technologies that allows you to kind of profile what's happening in the code, so you can look for bottlenecks and things like that. Okay, there's a few different things. And I say there's another optional one where you can run the examples code directly on the BeagleBone Black, which is really quite nice. And I will be showing some of the demos on the BeagleBone Black before we wrap up later today. But I've already mentioned, I've tried to make it as modular as possible, okay? So, you know, if you're sharing a module, or a module is shorter, maybe, you start with, introduction going down, or maybe you start and end at lighting, maybe you don't need. Okay, so yeah, so the material, it's modular. I'm sure Robert we'll go over the legalities of the content use later on, but it's all the slides are in their original format, so you can change things up, you can reword things, reorder things, and so on. So, for instance, if you have semesters like we do, okay, we tend to have sort of 12 weeks of sort of teaching, then there's plenty of lecture and practical content there. You could use the practical exercises as a continuous assessment. Obviously, you wouldn't provide the model solutions. If maybe with a final exam, or to be honest, in Hull, what we tend to do, particularly from the second year onwards, is for like graphics and so on particularly, we have 100% practical assessments, and I know some of my colleagues here also do the same. If you've got terms, they tend to be sort of 10-week sort of chunks, then there can be a lot less, in which case, you can reduce this to fit your thing. So say all the model answers are provided there. You might want to have a single exam if you so wished, or a mixture of the two, however you see fit. So today's workshop, okay, we'll be looking at the initial 4 lectures and 2 labs I've already mentioned. So essentially you'll be students for the day, okay? So hopefully you will gain experience by completing the labs, the practical experience. Hopefully you'll enjoy learning about the architectures and things from me. Now we will be taking lots of breaks. When I show you the agenda, we haven't put in the breaks because we'll just have them when we need to. But please make use of me, okay? If you have any questions anytime, please just raise your hand or something. When you're doing the practical lab things, then I'll be coming around. If you need any help with anything, then please do. You do have access, so if you don't complete everything, then you do have access to, in part of the package, the model solutions are there. I would suggest trying to do it yourself and get help from me so you can understand it in the first instance, okay? And also, for each of the labs, I've actually pre-recorded a video of me going through the lab, and you can see me live coding and so on. So that's actually included in the link is included in the printed material as well. So even after today, if you want to go back and see what's going on, it's all there. So essentially today's agenda. So I'll be going through the first 2 lectures. Now I will take a break after the first lecture so we can all have a coffee and pastry and so on. And then after the second lecture, you'll then be doing the first lab. And that's very much sort of, I think I renamed this to playing with PowerVR. So, it's essentially just allowing the students to understand what it is that they're going to be using. Then Robert, just before lunch, is going to introduce the university program for imagination technologies. So I believe that the mobile graphics that I've done is just one course package that Imagination have. So we'll have an hour for lunch, and then I will cover the lectures sort of 3 and 4, which is very much more about the understanding the architectures and the different SDKs and the graphics pipelines and things like that. Then you'll be doing the second practical, which is becoming more familiar with the SDK and the functions, and we'll actually be using that to load textures and things like that for us. And then finally, I will be showing just how you can, or basically doing a demonstration of particularly it's the lab work that you'll be doing directly from the BeagleBoard Black, as well as some other material. So I've put all the teaching material onto here, so I can show you. For instance, I'll show you the reflection and refraction, all working on here, as well as some of the examples from the PowerVR SDK, which all the OpenGLES 2.0 ones work directly on the BeagleBoard Black. And then we actually have, Imagination Technologies have been very kind and have bought 2 of these BeagleBoard Blacks that we will have a little giveaway at the end if you fill out your feedback forms. So, any questions before we get started? Thunderous silence. Excellent. Okay.